here's what you need to remember. That this conversation really started by thinking about something that was geometric. So we started with some term, a. And then we would have AR plus AR squared plus AR cubed and so on. And we did a little bit of manipulation here, didn't we? And we showed that this sum, if R was in the right range, would actually converge to what calculation? I hear mumbling. That's it. A over 1 minus R. And then, so the conversation was that convergence only happens when this statement is true. And you get some nice conclusions from that. So we started writing it this way. I wrote 1 over 1 minus x. Now, so looking at that, x has taken the role of R, and the first term is 1. So 1 over 1 minus x. Thinking of this function, right? That's a function. That function then must be equivalent to this infinite polynomial of 1 plus x squared plus x cubed, so on. So a is 1 in this case. Now, I hope you heard what I just said. So this function is the same as this one. This one is a polynomial. This one is not. Now, here's what that then means. And again, that's only true here. That's only true in that interval of convergence. So in this case, we would have said x is between 1 and negative 1. Probably would have wrote this. So what that means is I can choose any value I want. So if you have your calculator, I want to see if you can't help me out with this a little bit. I want to choose an x value in between here. Okay, so I don't know, a third. So I'm going to say x equals a third. I'm in this interval where it's going to converge, so that means 1 over 1 minus a third has to be the same thing as, by the way, what number is that? Try again. 3 halves. So that number, 3 halves, must be the same as 1 plus 1/3 plus 1/9. Do you see that 1/3 is taking the role of R? It's just that value squared, cubed, so on. So I want you to do this a little bit on your calculator to kind of convince yourself of this. Okay? So type in, I don't know, 5 terms. What you should actually be seeing right now as you're typing these in, if you're hitting enter in between, you should actually see the convergence. So after 5 terms, that's actually just a partial sum. We would say that would be the sum of the first 5 terms. It's not going to be 3 halves because we stopped, right? The dot, dot, dot doesn't exist. So what do you have after 5 terms? 1.49383? Is that what you said? So if you want another term, wouldn't you just take this number plus 1/3 to the 6th power, plus 1/3 to the 7th power, plus 1/3 to the 8th? So what you're noticing should be the convergence of these partial sums, so S sub 7, S sub 12, these are going to keep getting closer to 1.5. So what we're saying then for the power series, so the power series, we're actually talking about these functions. Okay, so this is the power series. And the reason is because these are just, these are polynomials with these whole number coefficients. So that's why it's called the power series, because we're adding them together.
So like if you add something like 2 plus x to the n, like 2 plus x equals the n, that was, and it says like find the power series, like what are we finding?
Let's do a couple more, okay? So hopefully you realize what we're doing is we're converging to a value here. So what the issue is that they're going to ask you for other kinds of power series, which is, I think, is really what your question is. So I had a few more here. I had 1 over, let's do that one. So the directions here might say, find a power series for that function. Okay? So what they're wanting you to find is something where there's x's to powers that are added together with some coefficient here that will equal this, in the same way as that last problem, so that we could approximate that answer. So what I mean by that, if I put an x value here, wherever it's going to converge, then over here, I should have then something that would give me that answer. Better and better, the more terms I add. So what we want to do is keep comparing this to things we do understand. And that's why when you click on the help me solve this, they don't really do that, which is why it's not helpful. So the first thing to notice is we know what this one is now, correct? And I should probably point out that we often are not going to write it like this. We're going to write it using summation notation. So we'd say here the summation from n equals 0 to infinity, right, ... of x. And this is kind of a creative step that we're just trying to find what exponent we should put here. And if you think about it quickly, x to the 0 is 1, then x to the first, x to the second. So this is another representation of the power series here in summation notation. Almost always 0 is where it starts. It could have been 1. You can change that and still have a true statement. If I would just put a 1 here, then it's just going to be n minus 1. So you're just kind of shifting it. You're getting all the same values. So there's actually more than one way to write this. But oftentimes you'll see, like 0 is probably the most common. Exactly. The first value you see here gives you the first term here. Jacob?
Like, what if the summation is something that's like super funky on the right side of it?
Yeah, we're actually going to do that with one here. So I think I'll be able to help you with that. So if you notice, so here's the whole point. We know this one. I want this to look like that. If I can make the red one look like the black one, then I can follow the same pattern. Agreed? So this is a pretty easy one. Perry?
The x is it's negative x, so like it's 1 minus x plus x squared. That's some summation.
Yeah, so okay, so first, do you notice that x, or x, which was the ratio, is really now negative x? That's the only way you would have got a plus here in the problem. You could say we have replaced it. So if I say it has to be a subtraction, what am I subtracting? What is the x that I'm subtracting? Well, it's actually negative x. So if you would write this one out, it would be 1. And if I wanted to keep the notation identical, I might write it this way first. But obviously, it does simplify. Okay? Are we okay with that first statement written there?
So for the 1, is that really 1 times negative x to the 0?
1 times...
How do we get the first
Up here, if you, I'm basing it off of this pattern. So this was a 1 already because we saw that in that geometric, right? Because remember, we started here and we made that. So that first term is 1. You could also say it this way. Isn't that the first term, a1 over 1 minus r, or a over 1 minus r? So that 1 is the first term.
So then negative x is like r?
So negative x is like r, right? Do you see that we keep multiplying by negative x? So here's what we should probably see here. It's really this then, isn't it? And that pattern keeps alternating plus minus. Jacob, did you have a question?
I was going to say, but you still have to make sure the x is between negative 1 and 1. Right?
Yeah, we haven't really answered that question. Now, let's do this. We knew here that x originally in this black had to be between 1 and negative 1. Our new x, that ratio, is negative x. Our ratio now is negative x. So that means that whatever this is now also must be between 1 and negative 1, or it won't converge. This is just a compound inequality that you can solve, right? So just think about, we'll just multiply every piece by negative 1 so that the middle is an x. Flip the sign. That becomes a negative 1. Flip the sign. That becomes a positive 1. Do you see it's actually the same statement? Those are saying the same thing. So this is the interval of convergence we now have.
So are we just always assuming that x is in between those two values?
Yeah, it had to be here, didn't it? So think about what you know about geometric. Like you would have been able to tell me this last year, that if I would write this out as a geometric, you should tell me that's never going to give me a value. That's never going to converge because it keeps growing. The only way for it not to grow is if it's between negative 1 and 1. So that's how I know this is true, which is now why I know it's true for this one. Now we're not done yet, because I want to practice writing the summation, because the next one is going to give us a little bit more of a fit with this. So, summation from n equals 0 to infinity. There's a couple ways I could do it. One thing we could do is, how could I get these to alternate? One clever way is to do something with a negative 1. Kylie? Negative 1 to the n will cause that to happen. Now, if you wanted the first term to be negative, you could have said negative 1 to the n minus 1 or n plus 1, just shift it over a little bit. So far, do you see that this would cause, if I would say what's this summation, it would be 1 plus negative 1 plus, put in 3, put in 2, put in 3, keep going.
How would you do like the limit as n goes to infinity of negative 1 to the n?
Can't.
Is it just or nothing?
Well, we're going to talk more about that later. So we don't have the right pieces yet. I also need x. So what do I need to include here? X to the n. Does that work? Or should it have been negative x to the n? Yeah, the negative is already taken care of. So you actually could have written it this way. See that those are the same? When the bases are equal, you could just put it back together. You have to have an x or we would never get these x's. Remember, you're trying to write out the function. So this is a clever way of writing out this infinite list. Okay? Which is also equal to 1 over 1 plus x. This original.
So 1 over 1 plus x is what that function that represents.
So we're actually saying they're equal. So 1 over 1 plus x is the same thing as this infinite list, or this infinite list, whichever one you prefer to look at. So again, if you pick a number between -1 and 1, anything you want, you could pick a half, let's say, and I would say, well, 1 over 1 plus a half, that's 3/2, so this answer is 2/3. So now put a half in everywhere you see an x, this is going to converge to 2/3. Okay? So that's why I'm saying they're equal. They're equal as long as we have the dot, dot, dot. As soon as I stop somewhere, there's now an error because I didn't include all the terms. So let's do a harder one. Because this is now where the book just, or the help me, it's not even the book. If you look in your textbook, it doesn't do this either. It's where the help me solves this does some kind of odd things. For ones like this, 1 over, I think I had 5 plus x. Let me double check. Yes, 5 plus x is what I want to do. Oops. And again, we should keep in our head that we know this one. We know what that does. So I want this to look like it. And it doesn't look very close to it at all. So in class on Tuesday, I was suggesting factoring. So if you look, the bigger problem is that this is a 5 and it's supposed to be a 1, right? That's the bigger issue. I don't really care if I change this, because just like that last problem, negative x is not a big deal. I can still think about times a negative x times a negative x, so on. So, Jacob?
So like when you say x, so you're not necessarily thinking about like x, like values, just that could be like any variable, right?
Yes. So maybe I should be saying r.
So that would still work, okay.
So whatever is going to sit here, do you recognize that whatever x stuff is there is the ratio? Looking at this pattern, if I can make that a minus sign. Perry?
So my confused, like, so right now, could you, like, because we already know that 1 over 1 minus r has that power series, like, could you basically just set 5 plus x equal to minus r, solve for r, and then that r value that you use in the power series?
5 plus x.
Is equal to 1 minus r,
Solve that for,
and then plug that back
you
in.
could. I don't want to do that. That's more what the help me solve this is doing, which I don't like.
So that's bad.
Because actually you're moving the center of it in a way, then you can't see something, okay? Because then they're going to turn around and say resubstitute for that, and then that's the step that when you look at the help me solve this, you're like, I don't know what they're doing. So I would say, let's do the same approach to find it, but let's write it this way. The first thing is, I can certainly do this. Just making that a 1. But then I can do this. These are just fractions, right? So I can mess with them like I could any other fraction. Are we good at this step? Now here's why I like this better. That don't we quickly know what this is in the parentheses? That if I want one more step, is that helpful? Can I quickly see what r is? The way I've written it here? Answer?
Yes.
Well, what is r? What?
Negative
Negative x
x.
over 5. So that means this power series, I'm almost done. This power series is 1/5 times. Now you might say, well, what am I going to do with the 1/5? Well, I don't have to worry about it, because isn't it, that's the power series. That's the thing I'm going to write here. It's just 1/5 times that whole thing. It's almost like I'm just going back to this statement. You know, we knew that this was this statement, right? Couldn't I just take this equation and go, oh, I'd like to multiply both sides by 3? You could do that. There's nothing wrong with that. That's all we're doing here. It's 1/5 times whatever this is. So if I was going to write this out, it would be 1. Why 1? Because that's the first term. I could say plus negative x over 5 to the first plus negative x over 5 squared, and so on. Dot, dot, dot. Now this is one that if you're asked for the summation notation, it's a little tougher. So let's do it. The 1/5 just sits there. This is the thing that's being added together, so that's what I'm going to try to write the summation for. You could do this in multiple steps. Now, the issue is that the way that I wrote this is probably the easiest way to see it. But if you had written down this intermediate step, you might have been more bothered. So if you would write this, 1/5, 1 minus x over 5 plus x squared over 25 minus x cubed over 125 plus x to the 4th over 625 minus dot, dot, dot. It becomes a little more obscured what's happening. So if you've written out your power series this way, I'm going to give you some tips on how to write the summation. Here are my tips. If we start this at 0, you don't have to make it all at once. So I see a fraction here, so I have a fraction. I can look at these as, look at the denominators. There's powers of 5, right? 5 to the 0, 5 to the first, 5 to the second, 5 to the third, and so on. So I could just say 5 to the n. I look in my numerator and I see powers of x. So I could say x to the n. What? We're not done? Okay. What do you also notice is happening? They're alternating. So that means there must be a negative 1 to the n. But do you notice that if everything has something to the n power, you could actually combine some stuff together, right? It's kind of like saying x squared times y squared over z squared. Oh, that is xyz squared. It's the same thing, that's all we're doing. But that's not how it's probably going to be written here. Here's why. Oh, don't know what happened. Crashed. Okay. It's going to be written this. Here's the final answer. Tell your neighbor why it's true. The summation from, sorry, I'll write it neater. Summation from n equals 0 to, my infinity's missing, infinity of negative 1 to the n times x to the n over 5 to the n plus 1. That's what the question is right now. Where'd the 1/5 go?
Yeah. So if you distributed this whole thing across every single term, I would be like raising the. Wait, why is it 5? What's negative 1? So it's like putting this 5th over there.
Five.
Would it help if you look back, look up here. This 1/5, this was a 1/5 on the outside. Wouldn't it distribute? So what happened? Somebody explain. Somebody explain. Michael? Speak way up so they can hear you.
By distributing the 1/5 across every single term in the series, it's like the power of whatever the term is over 5 is raised by another power.
Yeah, you're actually going to get an extra 5 in every term, is his point. So if you want an extra 5, how do you write that? Plus 1. Now, it's actually then true this statement. If I would ask you the summation of any constant times x, and it doesn't matter what's here or here, it's the same thing as if the constant is on the inside or the outside. And if you think about that, if I multiplied every term by k, or if I took the answer times k, all I've done is distribute or factor, multiply it through. So I just put it back in. If you wanted to see an intermediate step, I might have said, oh, I'll just put the 1/5 here. Oh, the exponents would just add, which gives me that. Why don't I give you one here to try?
Is there a preferred form of having it inside or outside?
Probably inside. Probably inside.
Can you do a standard at something?
Can what?
Like one of the ones like standard at 5, you know, like standard somewhere at 5, 0.
And then derivatives and then from
So, are we together? I don't want to feel like I'm talking to myself here. So we should actually be able to turn any of these kinds of things into, I mean, really all I did was choose a different value, didn't I? Right, it's a lot like the last problem. So I haven't said the thing about centered yet, so Dylan asked me about that, so I'm going to make that comment here in a minute. But you do this one, and maybe I'll make some copies. Who wants a paper copy to look at? Okay. That exam. Yeah, it should just be the positive x over 9. So then you'd have this negative 1/9 out in front. And if you're going to write out the terms, what would they be? Like so? Is that right?
Yep.
So what is the interval of convergence? So x, so that means that whatever we write here, we can only choose numbers here between, Jacob said -9 and 9. Is he right? Yeah, so Kristen, we could get that how? Doesn't. So here is where, if I say it's centered somewhere else, how that's going to change. Oh, did you write the summation? So -1/9 summation. So this one doesn't alternate, so you don't get that. If I look down here, I get powers of 9, so this must be n equals 0 to infinity. 9 to the n, and then I have an x to the n. So if I wanted to, that means I could write this as the summation of the opposite of x to the n over 9 to the n plus 1, and I better have my 0 to infinity. Did you get it? Again, there's a couple ways to write that. Hopefully you have one that's equivalent to what I just wrote. Now, think about this. Right now, we know that this is equal to 1 over x minus 9 on that interval. True? If I pick any number between -9 and 9, those two sides are equal. That's the whole point. And I have a graph here I think I'll show you of what I mean by that. But when it starts saying things like, I want this to be centered at, and then it says some other value, they're actually wanting you almost to like shift it somewhere else on the line. So instead of having it converge between -9 and 9, I want it converging somewhere else. I want it centered somewhere else. Now if you look at this, do you notice that it's centered at 0? That 0 is the center of the interval? Right? So I think the other day I just said, well, it's just a substitution. And maybe that didn't make sense to you. So let's see if this sounds better. That if this has a center at 0, right, between -9 and 9, and I would say I want it centered at 5, what would I do here? Less than, it's not 9 any longer. It's now
X-5 is still less than 9, right?
Why is it not less?
I don't know, I'm just writing what you're telling me.
No, it's in note 14.
That's not 14. It's 4. It's -5.
Would it be plus?
So, let's back up.
What did you say centered at?
Centered at
5.
5, I think is what I said. So, hang on. So all we're really doing is making a substitution for x. So if I would say, let me say it this way. We know what this is. And what if I say, I've changed my mind. I really don't want it to be x. I really want it to be x minus 5. Couldn't I just, anywhere I saw an x here, put an x minus 5? If this statement is now true, isn't that the first step that we did with the 1 plus r squared? We said, oh wait, it looks like that. So, and I say, wait a minute, what if I want it somewhere else? So here's the point, that if I've replaced, right now, if x is converging between 9 and -9, and I change it to x minus 5, do you see that I'm really doing something like subtract 5 from all of these? And I've changed where it's centered?
So X-5 is like a horizontal shift to the right.
It's a horizontal shift. That's all we're doing. So I've now shifted the interval of convergence somewhere else.
So does that mean any extensions in there you have to put X minus
Everything changes.
So everywhere is
So all that's really then doing is everywhere you see an x, we would now have an x minus 5.
so they all just going to be like a horizontal shift.
That's all they are.
The right side.
They're just all horizontal shifts.
So does the interval, how does the interval change? Does it do left side to everything to just cancel out again?
Well, it is the same interval in essence, but thinking about if I'm treating this as one thing, you're right, it is the same interval for x, but where's the center? So here's the other thing to keep track of the center. Like the center is going to be defined by these numbers here. It's also a notion of the trivial convergence. That may be a good thing to jot down, the trivial convergence. Here's what I mean by that. The trivial convergence. I want to go back to this statement. 1 plus r squared plus r cubed plus r to the 4th. And this was the sum, of all those things should be 1 over 1 minus r, right? With very little work, I can name an r value that I'm guaranteed I know that this converges to a number, so the two sides are equal. What is a trivial r value that forces the two sides to be equal with little thought at all? R equals 0. That's really the notion of where it's centered at. Okay? Because here's what happens. If I would make a substitution and say, there's now a new trivial value where this thing will converge for. What is the trivial value which this converges? It is 5. Now here's the point. We know that this can't converge at 5, right? It's supposed to be between -1 and 1, but we basically have shifted it. We've shifted the center to 5. So notice now this problem is going to converge where R now is between what two numbers? Here are lots of different answers. -4, -5, -9, -6. So this whole thing has to be between what two numbers still? -1 and 1. So R now is between what two numbers? -6 plus 5 plus 5 and you're just solving for R.
I know, but why do we do that for the first one? The first one we minus.
Oh, we erased that because I was just writing what you said. Right. Look, that's what we did here. Oh, that should have said plus 5. Sorry. Sorry.
So that one is,
So this should have been,
that's 14 to -4.
there you go. Well, yeah, so look right here. So -4 to 14. What's the middle? No, what's the middle between those two values? It's 5. Centered at 5.
So does it have something to do with the radius of the
Yes.
So basically whatever the
So here's all you then have to do. You just make a substitution at the very end. That's all we're doing. What do you want to ask me? Sorry I messed that up there. That probably confused you. Yeah, just in general. What do you want to ask?
So can we just use kind of like a substitution to make the general
That's-
form and then substitute?
Yeah, that's all you're doing. So you're going to find the power series, and I go, wait a minute, I want it centered somewhere else. You just replace, so if I want it centered at 7, you're going to replace x with x minus 7. If I want it centered at -5, you're going to replace x with x plus 5. And notice that you have to then change, you have to change where the interval of convergence is. But it better be now centered at that number. It's just the horizontal shift of the graph that you're doing.
This is about a separate topic, still sums though.
Any questions on centered? Dylan, does that answer the question about it being centered somewhere else?
just add or do the opposite of what's ever done to the x.
Yeah, just think solve. Just think solve. Colin? Here's the last thing I just wanted you to see, and we're not. I don't have, my function doesn't quite work right now. This is the one, I was wanting it to be where every time I increased n by 1, it added the other term, but right now some of the terms are undefined, so it doesn't work. So don't look at that yet. Don't worry about it. But we wrote out this power series, didn't we? This was one we did earlier. Where did it converge between? What two values converge between? -5 and 5. Okay? So that means looking at this graph, when we write out this other polynomial, it's only ever going to fit this curve between the values of -5 and 5. That's why we're saying it converges. So what I have are the first 10 terms, and the 10th one will work for us. Here's the 10th, adding up, actually it's the first 11 terms, 1 plus, and it kept going. So when you notice this, do you see that we're fitting a polynomial to something that is not a polynomial? And so what this is saying, this is through the first x to the 10th term. That means I can keep getting it closer and closer, but it said it converged. It's parenthesis 5, right? It's less than. They're not equal to signs for there. So, I mean, I'm never going to get it to converge at -5, am I? Asymptote. But then I'm also not going to be able to deal with it over here.
So what's the red graph right now?
So the red graph is the power series through x to the 10th.
Just the sum of all the terms?
It's the sum of them, yep. It's the sum of the first 10 terms. Ignore these. Ignore those. That was me trying to make it more dynamic. Didn't work yet.
So the
Purple is this.
one of red and 5.
The red is the first 10 terms, first 11 terms of the power series.
So you keep getting bigger and bigger.
So if I would add another term, what's going to happen? This gap should close.
So it's getting closer to that.
Yes. So notice how well it fits in here, though. Do you notice how well it fits at the center? Like, so if I would ask, so here's what we'll stop with. It's going to calculate here for me. So what if I calculate that of 0? It says 0.20. Let's get some more digits. Do you notice how well it just did? If x is 0 for this function, you can see the answer is 1/5. Sketchpad is saying 0.20000. Now, if it could show me more decimals, there's probably not all zeros there. But it's fantastic fit. The key is at the center. So that's why if we can shift it, we could get this thing to fit different things in different places. So if you wanted a copy, paper copy, grab one on your way out. See ya. Don't try it.
There was, one of the problems on the test was